Hey everyone, Mr. Voikin here. This is lesson 1.13 on Venn diagrams, pages 47 to 51. So what are Venn diagrams? Well, they are circles or other objects or shapes that are used to give sort of a visual relationship. So a visual relationship between a number of sort of items, so how they are related. And they are usually circles, and we'll start off with an example right here. That's sort of the best way to illustrate this. So now usually you're going to be given some information, such as we asked a bunch of students in a class what their favorite subject was, math or English. So we're going to say that 9 students selected only math. And that word only right there is going to be really important. Okay, and 6 students selected only English. Okay, and again, that word only, you need to look for that word. If it's there, it changes the whole meaning of it. And we're going to say that 5 students, they like both of these subjects, and we're going to say that 3 students don't like either. Okay, and like I said, we usually put this into a, usually circles to set this up. And let me just move this out of the way or minimize it a little bit. Put it up in the corner here, and we're going to draw a couple circles. So we'll start with a blue circle right here, and that can be math. And then we'll grab another color like a red circle right here, and that can be English. And then we're going to start filling in the numbers. So anything that's in this section right here is only math. Anything that is in this section over here is only English. Anything that is in this section on the outside is neither. And this section that's right in the middle, sort of forming this football shape right here, is going to be both. Okay, so in here, that is going to be both. Now, let's just fill in some of these numbers. So 9 students like only math. So where are we going to put that one? Well, we're going to put it off to the side here, the number 9. And 6 students like only English. That's going to head over here on the right side into that section that is only English. We see that 5 students like both. So we know that the number 5 is going to go in the middle, and we know that 3 students don't like either. So in this case, because we're talking about 9 that only like math, 6 that only like English, 5 that like both, there are some questions we can ask. So if I was to ask, for example, how many students? So let me just grab a blue pen right here. So how many students participated in this sort of survey? Well, it would be 9 plus 6 plus 5 plus 3, which is going to be 15, 20. It's going to be 23 students. Okay, now, how many students like math? How many like math? Okay, now this is where we got to look at back here, this word only math. Remember, that is this one right here. But all these students that are in the middle, they like both math and English. So really, how many students like math? Well, the answer is going to be the 9 that only like math plus the 5 that like both. So 14 students are going to like math. So how many students like English? Okay, well, it would be the same scenario. We know that 6 like only English, and 5 like both. So we have a total of 11 students that like English. Now, when it's worded in this way, again, with this word only, it's quite easy to set it up, but it's not always worded that way. Okay, so let's take a look at another example. And if you notice the difference here, we're missing a word, and that word we're missing is only. They like only monkeys. In this case, we just know they like monkeys. So when we say that a student likes both, that means they like monkeys also, and they like sloths. So they like, well, slows, they are slow, sloths. So they like both. So with this one, what you sort of have to remember is we're going to start off with both. Always start off with the both. Okay, so let's again start with a circle, and we're going to say that this one is M-O-N-K-E-Y-S, monkeys. And we'll make another one right here, which is going to be sloths. Okay, and we're going to start off, like I said, with the both. So how many like both? Well, in this case, we've got 10 students that like both. So we know that they like monkeys, and we know that they like sloths. So how many people like monkeys? 15. So if 10 like both, that means those 10 like monkeys. And if 15 people like monkeys, basically this is going to be 15 minus that 10, which is going to be 5. Okay, so 5 people like only monkeys, but a total of 15 people like monkeys. So we would do the same type of calculation for sloths. So we know that 10 people like both, that means 10 people like sloths. 28 students altogether like sloths. So this one is going to be 28 minus those 10, which is going to leave us with 18. So 18 like only sloths, but 28 like the sloths. Okay, so for the monkeys, the people that like the monkeys are going to be in this section, which is right here, and that's the only section, as well as the both. And the people that like sloths is going to be in this section right here, along with this middle section, which is both. And then the last one is going to be how many people like neither. And the answer in this case is going to be, oops, sorry, just trying to get another colored pen there. It's going to be 8 students, and that's going to be outside there. So again, if we're asked a few questions, so how many students in total? Well, again, that's going to be the only monkeys, plus the only sloths, plus the both, plus the none. So we got 23, 33, we have a total of 41. Okay, and like I say, normally we're going to see these numbers like this. It could be reverse, where you don't see the words up top, and that's not going to be visible, and that's not going to be visible. So again, if we were to ask how many students, many like monkeys, that is going to be the 5 that like only monkeys. So remember, in here, this is the only, and in here, the middle section is the both. So both and only, both like monkeys. So we have 5 plus 10, which is 15. And when we ask how many students like sloths, again, this one right here is the only, and we're going to have to take the only plus the both, and we've got a total of 28. Okay, let's take a look at the last example, and it's a little bit tougher or a lot bit tougher depending on the way you look at it. But we're going to go through it anyways, and hopefully it'll help you to answer the questions in the classwork. And if you find a similar question like this difficult, just refer to your notes or watch the video again. So one thing to make note of is that in the last two examples, we didn't tell you how many students or how many people were involved in the survey, but that is the first thing they tell you right here. So they're telling you there are 50 students. And remember, again, in the second example, I said, you know, whenever we don't have that word only there, we want to start off with the middle section, the combined section that has both things in common. But this time, what's happening? They're saying that how many people like both. So it's almost the opposite. We now don't know how many people like both, but we know how many people are involved. So the next thing we need to do is look at the middle part and see if there's like an only in there, or if it refers to people that only and both. And it says 36 people like green. Okay, so 36 people like green. Okay, so if that's the case, it means that is not only the people that like only green, but it's the people that like both. So this is only and both. And if we look at the next section, which is talking about the purple, we can see that 40 like purple. Okay, so again, it doesn't say only purple, so that means that it is only and both. Okay, so we're going to start off, as always, drawing our Venn diagram. So we've got a green circle right here, and I got a purple circle right here. The purple one is people that like only purple, and the green one is people that like only green. And don't forget this middle section where it's overlapping are the people that like both. So where did I say we're going to start off? Here. This is the first place you want to start off, in that middle section. So how many people like both? Well, the answer is we don't know. So that's what we're actually trying to figure out. Now, instead of using a question mark right there, we could use a box to say fill that in or something like that. But really what we want to get used to using is a variable. Now we could use a variable like b for both, but you got to be careful that that doesn't start looking like a 6. So one of the most common variables to use is an x. And again, with the x, you got to be careful that you don't do an x like that, because that looks like the multiplication sign. So how would I make an x as a variable? I do a backward C and a forward C, and you sort of have this curved little x. So that means an unknown number of people like both. So how many people like green? The answer is 36. Well, what does that mean, the people that like green? That is the people that like only green and the people that like both. So 36 people like green. Then what we need to do is we actually need to go in here and say, well, then the people that only like it is going to be the 36 minus the people that like both. Remember, this represents both. Okay, so we would do the same thing for the purple. It's going to be 40 people like purple, but we got to minus the people that like both to tell us who only likes purple. So basically that is going to be only. And this right here is going to be the only. Okay, so how do we solve for the x? Well, if you can get to this stage right here, that's pretty good logic and understanding. But now we just need to lay it out. So we know that the people that only like green plus the people that only like purple plus the both is going to be the total number of people. So that equals the total number of people. So this plus that equals the total number of people. And so we just need to lay it out exactly like that. So what is the total number of people? 50. What does it equal? Well, it equals the only, which is 36 minus x, plus the both, which is just x, plus the only purple, which is 40 minus x. Okay, so now what do we need to do on this side over here? We need to combine like terms. So you can see that even while we're doing Venn diagrams or other things, we're going to be bringing algebra into there. And this one's a little bit complex because it's going to be a couple different steps in order to get the final answer. Now, remember what this equal sign means. It means that whatever's on the left equals whatever's on the right. So they are balanced. Now, again, the first thing I want to do is combine like terms, so let's do that. Now, what you want to do is circle the terms that are the same. So here's a number 36 and a number 40. I'm going to change it like that, number 40. So if I have 36 and 40, let's put the equal sign back here. I have a total of 76. So I can cross those out right now because I've already dealt with those. Now let's deal with these x's. I've got a negative x and a positive x. So whenever we have a negative 1x and a positive 1x, they're the same. One negative, one positive, and they literally cancel each other out. But that leaves us with one negative x down here. So I've got a minus x on this side. And on the left side, I still have those 50. Now the goal of algebra is sort of to take all of the variables. So I want to put the variables on one side. It doesn't matter which side. And I want to put numbers on the other side. Okay, so remember, that's our goal, is to get variables all on one side and numbers all on the other side. So let's look at the right side. Is 76 a variable? Because we're saying right here that we want only variables on that side. Well, 76 is a number, not a variable. So how do I move that 76? Well, I minus 76. That's going to be 76 minus 76, which is going to be 0. So really what I've done is I've eliminated that number from the right side. But is it balanced? No, because if I take something away from the right side, I need to take it away from the other side to keep it balanced. So I need to minus 76 over here. And 50 minus 76 is negative 26. Now we're dealing with integers as well. So you look right here, everything's sort of starting to come together. We're dealing with Venn diagrams, but we're now bringing in algebra and integer math. So you can see that having this strong base is going to be really, really important. So let's just rewrite this again to see what we have on the left. On the left, we've got negative 26. And on the right, these 76's canceled each other, so all I have is a negative x. Now, this is, whenever you see this, a negative x, we're trying to figure out what is the value of x. We're not trying to find out what is the value of a negative x. But this will happen quite often where the x is finally sort of isolated on one side, but it's negative. Okay, and really, all you have to do is just change the signs of both. So this would just can be rewritten as x equals positive 26. Okay, now if I had another example, just do it off to the side here, like negative x equals 14. Again, are we trying to figure out what a negative x equals? No, we're trying to figure out what a positive x equals. So what am I going to do? I'm going to keep my equal sign there and change the sign of both. negative x becomes x, and positive 14 becomes negative 14. Now it's good to understand, well, why? Why can we do that? Well, there is a number in front of this x, and it is a 1. So it's a negative 1 that's in front of there. And basically what I'm going to do is I'm going to divide this side by negative 1, and to keep it balanced, I'm going to divide the other side by negative 1. Now, let's look on the right-hand side. What do we have? What is negative 1 divided by negative 1? Well, that's a positive 1x. So positive 1x. And again, we just don't write the positive and we don't write the 1. We just leave it as x in a simplified form. On the left-hand side, what do I have? I've got a negative 26 divided by a negative 1. 26 divided by 1 is 26. And negative divided by a negative is a positive. But again, I don't need to write that negative sign, or that positive sign. Now, most people don't leave it like this, where it's 26 equals x. The usual way to see it is x equals 26, but really they mean the same thing. So last thing we need to do is check. We need to check if this is correct. How do I know that 26 is right? Okay, well, we're going to go back up to the top. And remember, x is equal to 26. So if I've calculated x is 26, the only green is 36 minus x, which is 36 minus 26, which is going to be 10. And on the other side, I've got 40 minus x. And what is x? 26. So 40 minus 26 is going to be 14. So 14 people only like purple. And in the middle, that x is replaced by the value that we calculated, which is 26. And remember, how do we calculate the total number of people that are involved? We take the only on one side plus the only on the other side plus the both. So that is going to be 10 plus 14 plus 26, and that equals 50. So we know we're correct, and we're done this question.